And coming to the concept of convolution, it is a mathematical way of combining the two signals to form a third signal. So the convolution theorem is a fundamental property of the Fourier transform. So here the convolution in time domain equals to the multiplication in the frequency domain and vice versa. So time domain, convolution in time domain will be equivalent to multiplication in the frequency domain. We should remember this concept. And here we are having two different convolutions, linear convolution and circular convolution. And the linear convolution symbol is asterisk. So y of n is equal to x of n into h of n. X of n is my input signal and h of n is my here a second input signal h of n, right? So we will have our signal like this. So y of n is my convoluted signal. So how many samples we will have in our output signal y of n? So we have to calculate that. So here for doing that calculation, we have to calculate the number of samples present in our input signal x of n, let it be L, and the number of samples present in my h of n, let it be M, then L plus M minus 1. That is the so many number of samples we will have in our output signal, that is convoluted signal, right? And coming to the zero circular convolution, here you have to go for the zero padding procedure if the number of signals in x of n and h of n is not equal. But while doing the linear convolution, we don't mind about the number of samples present in x of n and h of n, whether it is equal or not. We don't mind about that. Directly we can proceed with our linear convolution. But if you are going for circular convolution, first step we have to check for the number of samples present in x of n and h of n. If it is equal, then we can proceed our convolution process. If it is not equal, first make it equal by doing the zero padding procedure. Zero padding in the sense appending zeros in with your samples at the right side, right? So you have to add your zeros at your signal. So if I am say if I am imagine the zero padding concept in the image processing, then I will have a black patch wherever I had my zero padding procedure, right? You can imagine in this way. We can correlate this circular convolution concept in your image processing in this way. So zero padding, we have to do the zero padding procedure, right? If the number of samples in x of n and h of n is not equal, right? And then we can go with the circular convolution. So in the circular convolution, again we are having two different concepts: matrix circular convolution and concentric circle method, isn't it? So we are having two different procedures we are having. So concentric circle method and matrix multiplication method. So but if you are doing with the MATLAB, then it is very easy while going for the matrix procedure. Then we can easily represent our samples in the matrix form, in the array form in our MATLAB. Then we can easily go with the circular convolution in that.